Let's look at some word problems and figure out how to write a linear equation to represent those word problems. So I've got a canoe rental service. They're going to charge a $20 setup fee just to transport the canoes to the location, and $30 per hour to rent a canoe. We want to start by writing an equation to represent the cost of renting a canoe for H hours. So I might recommend thinking about the problem and just coming up with a few sample points. Clearly, how much you pay depends on how long you rent it. So H is my independent variable that we can control, and the cost depends on the hours. So hours and cost. If I rent it for 0 hours, I'm like, yeah, I want to do this. I pay them to get it to the river, and then I'm like, oh no, actually, I don't want to rent it. I still have to pay that $20 setup fee. If I rent it for 1 hour, I'm going to have to pay the setup fee plus that $30 for that hour, so I'm going to pay $50. If I rent it for 2 hours, I'm going to have to pay 2 times $30 per hour, or $60, plus the setup fee. So 60 plus 20 will cost me $80. So the cost is going up by 30 every single hour. That's my rate of change. So how much I spend, my cost, that's going to equal that $20 setup fee plus $30 per hour. There's an equation representing the cost in terms of hours. So that's the answer to question A. Question B, what would be the cost for 24 hours? Well, for B, the cost is going to be that $20 setup fee plus $30 per hour for 24 hours because I kept it for a full day. So I simply replace the hours with 24 hours. Well, these numbers are going to get big, and I don't want to make a silly mistake in a video, so I'm going to use a calculator. No shame in that. 30 times 24, that's going to cost me a lot. So it's going to be $20 plus $720 for that full day. So my total cost is going to equal $740. Now I want to point out to you that this is a linear equation. It should look familiar to you if I were to just slightly turn it around. I'm going to say that the cost is $30 per hour plus the setup fee. That should look kind of like this. Y equals mx plus b, where x is my hours and y is my cost, and my rate of change is 30. And b is 20, because this point 0, 20, if I was going to graph it, that would be the y-intercept. See, when we go to make this graph, we're going to have some place we start at 0 hours or 1 hour or 2 hours. Well, at 0 hours, it's going to cost us $20. Let's count by tens. 10, 20. It's going to be right there. And after 1 hour, it's going to cost me $50. 20, 30, 40, $50. I'm counting by tens. Oops, that goes there. And after 2 hours, this is the wrong point. After 2 hours, it's going to be way up here at 80. And I've long made a mistake there. I'm going to use my straight edge. I'm going to draw my line. My graph would look like this. Notice I didn't do 24 hours. That would go way out. But I also need to label my axes. These are my hours. I might go a little further. And this is the cost in dollars. So you want to label your axes. Sorry about that. Let's do another one. Oscar's collected 100 pounds of aluminum. That's what he's starting with. He plans to collect an additional 25 pounds each week. We want to write an equation for the total pounds collected after W weeks. And then we want to figure out how much he'll have collected in 1 year. So again, time is always my independent variable. But how many pounds he's collected depends on how much time has passed. Now, when he starts and there's no weeks that have passed, apparently he's already collected 100 pounds. After a week, he'll have collected an additional 25 pounds, so he'll be up to 125 pounds. And after week 2, he'll be up to 150 pounds. And after week 3, he'll be up to 175 pounds. And after week 4, he'll be up to 200 pounds. Now, we could continue with this chart. Hopefully you all know how to count by 25s. You know your multiples of 25 if you've worked with coins and you know a quarter is worth 25 cents. But we don't want to go all the way out to 1 year. 1 year, by the way, is 52 weeks. That would be an incredibly long table. We would much rather have an equation that we could use. So my number of pounds P that he has collected is going to be that 100 pounds he started with plus 25 pounds each week. So times the number of weeks. We can check if this works. If I plug in a 1 for W, weeks, I'd have 1 times 25 is 25 plus 100 will give me 125 for my poundage. Let's check for 4. 4 times 25 is 100 plus another 100 would give me 200. So this equation is correct. So that's our answer for A. How much will he have collected in 1 year? Well, we're going to plug in for the weeks 52 because there are 52 weeks in a year. So for part B, we're going to say the poundage that he'll have collected will be that initial 100 plus 25 times 52. And for that, you want to use a calculator. 25 times 52 is 1,300 plus that initial 100 pounds. So his total pounds collected in 1 year will be 1,400. So 1,400 pounds in a year. Now, we're not going to graph this one, but once again, just like the last example, this is basically a linear equation. When I take P equals 100 plus 25W, I could just slightly rearrange it, P equals 25W plus 100, and instead of saying pounds that depend on weeks, I could say Y depends on X. And I would graph the equation Y equals 25X plus 100. This would be my Y-intercept at 0, 100. And this would be my slope, which is the same thing as your rate of change.